Hi everyone, this is Dr. Chung. We're gonna start the AMC 8 from today. Okay, so what the test will be on January next year, so we can go a little faster. Okay, all right. So this is AMC 8, the book that I published on Amazon.com. Maybe you can take a look over here. Okay, so how to start with these books? Okay, you can see from number 1 to 6. That makes your help to prepare the AMC 8, okay, with this book. Right, the next one is, okay, this message my from me, okay, why AMC 8 is very important, okay, for the student, especially for the student who are really, okay, like the math, okay, so this is very different curriculum from your school academic curriculum, okay. This with a lot of help for special reasoning, logical reasoning, and advanced mathematics. Okay, if you really want to be a top in the world, right, in mathematics, you have to try this book. Okay, and here is the tables of topics. Okay, so we started from number one. There are 53 topics to prepare MC8. Okay, this is the topic one, the integers. So you can take a look. Okay, what is the whole numbers? What is integer, positive integer? Okay, something like that. So we're gonna start. So just simply, I'm gonna explain. Okay, what is the numbers? Okay, today. Okay, I'm gonna make it big. So we have the numbers. We have two different numbers. One is real. The other one is imaginary. This is real. The other one is imaginary. Imaginary, we don't know, right? We can see these numbers, okay? So just we take a real today, okay? Real. The, this real number can be divided into two numbers. One is a rational number. The other one is the irrational number, okay? Yeah, rational number is defined as this number. Any numbers can be expressed as A over B, which is a fraction. This is a ratio, right? Ratio means what fraction or A to B, something like that. But in this case, A is integer, B is integer, right? A and B must be integers. But B cannot be zero, right? Okay, rational numbers. So 2 is a rational number because 2 can be expressed as 2 over 1 or 1.5. That is a terminating decimal. Also, I can be expressed 3 over 2. What is the irrational number? Irrational number is what? On repeating is correct. Decimal. Okay. Okay. And that or non-terminating, right? Yeah, plus non-terminating. Decimal. This is why irrational number, okay? But over here, repeating decimal, okay? Yeah, repeating decimal is non-terminating, but it is repeating. I'm gonna use my repeating decimal over here. Repeating decimal. Repeating decimal can be expressed via in fraction. Okay, that's why this repeating decimal belongs to rational numbers. Okay, for example, 0.3333. This one equals to what? 0.3. We use the bar or dot, right? Because this is what, 1/3. Okay, so this is it belongs to rational numbers. What's the difference between rational and irrational? Rational numbers on the number line. We have a number line over here. Left. to the right. So we have some tick number, right? 0, 1, 2, 3. And to the left-hand side, we use negative, right? Negative 2, negative 3. We know that where is rational number. We can mark it. This is we can mark the numbers. Right, that is a rational number. What is the 1/3? Yeah, when you divide it by over here, 1/3. Yeah, this number is repeating. Repeating decimal, we can mark this number on the number lines. Okay, so that is belongs to rational. What is irrational? Something like this one. Square root 3 or pi or e number, that is non-repeating and non-terminating numbers. Where is this number? Square root 3. Okay, where is square root 3? Square root 3 is actually 1.7321 and keep going forever, never stopped. So we know that this number will be around here, right? 1 point around over here. We never stops, so we never mark this number. That is irrational, different. Still shaking. Where is it? Yeah, around this point. 1.732, 1, 2, 2, 2, between these numbers still tumbling, right? We never mark. Yeah, that is the irrational number. But we know that we get something around this number, right? Okay. So rational numbers, we have integer number. The other one is the decimal or fraction, right? They're all decimal. So integer is three different. 0, greater than 0, 1, 2, 3, 4. On the other side, negative 1, negative 2, negative 3, and negative 4. Okay. 1, 2, 3, 4, this positive integer, we set positive integers. For these positive integers, there is some additional or special numbers. Special name there. Okay, what is that? Natural number or counting number or counting integer, okay? When you count some money, we start from $1, $2, $3, $4. We never start from 0, okay? And the one is a whole number. Whole number to the positive integer, we add a 0 over here, okay? So 0, 1, 2, 3, 4. This is that whole number. You know what's the difference between natural number and counting number, right? This number. Okay, negative 1, negative 2, negative 3, negative 4. This is, we set negative integers. Okay, and the one is 0, we set some neutral number. Okay, so this 0 cannot belong to positive integers and negative integers neither. Okay, it never belongs to here. Okay, yeah, that is the real number. Okay, imagine number, maybe when you go to a 10th grade, 9th grade, we'll start this one. Okay. And sometimes we use what consecutive numbers. I'm gonna go to here, right? Okay, I'm gonna go in the book over here. Consecutive integers. Okay. Remember what is the consecutive integers? Consecutive integers, there's no gap, just increased by 1, something like this one. 3 consecutive integers, 3, 4, 5, or 6, 7, 8. There's no gap, right? That's increased by 1. So another example, we have 4 consecutive integers, 10 plus 1, 11 plus 1, 12 plus 1, 13. Okay, they are all what? Arithmetic progression, right, with the same difference, okay? So general representations, if n is integer, Three consecutive integers can be represented as this way, n plus 1, n plus 2. Or sometimes you can use n plus 1, and minus 1. This is another expressions for the what? Consecutive integers. Sometimes this is useful. Okay? When you have odd numbers of consecutive integers. That is better, right? Odd. Even is what? Better, even consecutive integers. Okay? n plus 1, n plus 2, n plus 3. Okay? All right, the next one is consecutive even integers. This is what consecutive even integers. If the first number is even, second number is what? Plus 2, third number plus 2 again. If this one is even integers, the next number is n plus 2, n plus 4, right? Consecutive odd integers, it's the same thing. If first number is odd, the next consecutive odd integers will increase by 2, right? n plus the same expression. It depends on the first integer is even or odd. Okay? Maybe sometimes we can use even integers is 2k. The next even integer 2k plus 2. The next integer is 2k plus 4. K should be integer, right? You can use this one too, but I like to use what this way is better, okay? All right, this is AMC 8 practice questions. You can take a look over here. So we're gonna try some past exam, past right questions, previous questions over here, right? Listed in AMC 8. So we're gonna try number 1. Sum of 6 consecutive positive integers. They should be positive integers. That is 2013. So what is the largest of these 6 integers? Maybe by definition you can define 6 consecutive positive integers. If n is an integer, positive integer, second one is n plus 1, third one is n plus 2, and n plus 3, n plus 4, we have a 5 there, right? 6, one more, n plus 5. You can express this way. How many is there? 6n. When you add all this one, that is 6n. But there's some constant, 1 plus 2 plus 3 plus 4 plus 5. What is the sum of these 5 numbers? 6, 6, and 3, right? So 12 plus 3 is what? 15. That is the sum of 6 consecutive integers. That is equals to 2013. When you subtract 15 both sides, how much this one? 8, 0. Minus 1 is 10, right? Okay. 9 and 1998. After that, you can divide by 6 quickly, right? 18, another 18, 3, 18 equals 0. The first number is 333. So which one is the largest of these 6 integers? n plus 5, right? You add 5 more to that number, okay? So 333 plus 5 is what? 338 is the answer, okay? Or sometimes we can use the properties of arithmetic sequence. Arithmetic sequence, this is the 6 number, 1, 2, 3, 4, 5, 6 numbers. Arithmetic is with the middle number exactly equal to the average in arithmetic sequence, right? They increase by 1, that is arithmetic increase by 1. Middle number is actually equals to, this is the median, is actually equals to average. Sometimes we use this properties. When you divide 2013, then divided by 6, that's the average, right? 2013 and divided by 6. Take a look. 18, 21, 3, 18, 33, and 5, 30, another 35. 335.5 is the average. That is the median. This number in the middle between two numbers will be 333.5. Sometimes we can use this one. What is the next number? 334, right? So two more. I'm sorry, 330, 35, not 33. The next number is 336. Okay, sorry, okay. Yeah. The screen is so brighter, that's why sometimes I can see the number. So that is the next number, and two more numbers, that is plus 2, right? So the last number, okay, this number is 337, 338. Okay, yeah, the largest integer, and this consecutive numbers will be 338. Sometimes we can use the properties of arithmetic sequences. Okay, right, remember, the median is always equal to the average and arithmetic sequence. Maybe you can learn what is the arithmetic sequence next time, okay? All right, you can try number 2. At this time, that is a consecutive odd integer, okay? Maybe we can try this one. Okay, we can try. So which of the following integers cannot be written as sum of 4 consecutive odd integers? Maybe we can let this one. The first number, n, is odd. What is the next number? N plus 2. And n plus 4, and n plus 6. Okay. Okay, follow definition, right? That is it. I think that is the best way. Or you can use why someone looks like n plus 1, n minus 1, because they are another m plus 3, okay, and minus 3. But this is another way to express, right, consecutive odd integers. Okay, right. But I like to follow the by definition to avoid confusion. Okay. Okay, this number should be odd. We know that it can be even. Sum of all these numbers, how many n's there? 4n, right? And how many, what is sum of the constant numbers? 2 plus 4 plus 6. Okay, 12, isn't it? This is the sum of the right odd consecutive integers. First, we can try number 16. Because what? All options is given, so we have to check it, okay? All right, we have to check it, or other things given. So 4n equals plus 12 equals 16, first number, option A. 4n equals 4, when you divide it by 4, n is 1, right? But it should be odd, right? Yeah, 1, 3, 5, 7. That's possible, right? What about 40? Quickly, 40 over here. 4n equals 40 minus 12 is 28. When you divide it by 4, n is 7. Also, that's fine. What about 72? 72 over here. 72 minus 60 is 60. Minus 12 is 60. Divide by 4, 15, right? And it's 15 is odd. That's fine. What about 100? 100 is what? 88, right? Minus 12 is 88. When you divide by 4, n equals 22. But this n is an odd number, right? So 100 cannot be expressed in these 4 consecutive odd integers. Okay? So choice D is the answer. Okay? So our other one is you can try, if you have the book, or this one, right? That is not hard. You can do that by yourself. Okay? Right. This is odd and even integers from some practice questions and the previous past questions. Okay, you can try this one by yourself. Okay. There's the answer key there. very detailed expression, step by step. Okay, you never miss the questions. So you must write clear, all right, about this AMC 8 using integers, the profitable integers. You have to figure out and to complete it, right? And for preparation for AMC 8 questions about these topics, okay?